everyone, I am Darshini Ramu. Today we would like to talk about the GPS survey project presentation. We are from group 5. So the introduction of GPS or GNS overview is what is GPS? GPS is Global Navigation Satellite System. GNSS is a satellite system that is used to pinpoint geographic location of a user's receiver anywhere on land and sea, in the air or in Earth orbit. A common terms of GPS: GLONASS, Galileo, ViewDow, QZSS, and NAVIC. GNSS are used in all forms of transportation: space stations, aviation, maritime, rail, road, and mass transit. Positioning, navigation, and timing (PNT) play a critical role in telecommunication, land surveying, law enforcement, emergency response, precision, agriculture, mining, finance, scientific research, and so on. They are used to control computer networks, air traffic, power grids, and more. Next slide. The GPS is the global positioning system. Originally, navigation, satellite timing, and ranging. GPS is a space-based trio navigation system owned by the United States government and operated by the United States Air Force. Next. The advantage of GPS is first, positioning accuracy from 10 meters down to the sub-centimeter level, available to all users anywhere on the Earth. Internet positioning, all-weather system, no user charges, available 24 hours a day. Next slide. Here the picture shows the GPS fleet tracking system. You can have a look. Next slide. Disadvantage of GPS is sometimes GPS may fail thanks to certain reason and terrain costs. You would like to hold a backup map and directions. If you are using GPS on a battery operated device, there could also be a battery failure and you will need an external power supply, which isn't always possible. Sometimes GPS signals aren't accurate thanks to some obstacles to signals like buildings, trees, and sometimes by extreme atmospheric conditions like geomagnetic storms. GPS chip is hungry for power which drains battery in 8 to 12 hours. This needs replacement or recharge of battery quite frequently. GPS doesn't penetrate solid walls or structures. It also suffering from large constructions or structures. Next slide. So here we can see the GPS applications so we'll be using for mapping, surveying, and then for aerospace, and then weather.
Next, we are going to see the orbit computation. But firstly, we are going to open the MATLAB application. And then we are going to open the OpCal and PlotM as the main program of this subroutine. Followed by the set post new M file, which is the subroutine of this computation. The next one is the file of the set post new M and OpCal and PlotM being opened together so that the file can be able to run. The next one is orbit computation coding process. Which we can see from the picture here. Next one is how to produce orbit computation process, which is we go to OpCal and PlotM file and click on run after finishing coding. After that, when the question which PRN do you want to use, meaning that it wants the user to request and state the the number of satellite, which is also known as pseudo-random noise code. Pseudo-random noise (PRN) also is a vital code division based on satellite navigation system, and this is to identify accurately which satellite is to receive. And in this exercise, we choose number 8 PRN as our choice, as between the satellite from 1 to 32. After finish choosing, we click on enter and the output will come up. And this is the output that come after we click enter, and after we choosing the satellite number, and the picture beside show the output of the selected GPS and its orbit computation. The yellow line shows the movement of the selected satellite and how it orbits around the Earth. Okay, next, then navigation solution. I will give it to Darshini Kalemani.
Navigation solution. Navigation refers to the method of determining aspects such as position, speed, and direction during travel. In the pre-modern era, direction and position were determined using an azimuth, a compass, and a map. These are now considered primitive forms of navigation. As a result of modern development in science and technology, exact position and speed are determined using equipment such as artificial satellites, global navigation satellite system (GNSS), inertial navigation system (INS), and etc. In modern sense, navigation is mechanical devices equipped in ground vehicles, ships, and aircraft to determine their position. Next. So in navigation solution, we are going to use 4 satellite coordinate X, Y, Z. So first of all, we need to declare the speed of light c, and then we need to declare the XYZ coordinate of the 4 satellites, satellite 1, 2, 3, and 4. Then we need to declare the approximate coordinate of satellite. Next, after we declare the all satellite coordinates, we need to do a linearization of the geometry range. This is the formula for the geometry range. So in MATLAB, we declare the geometry range as rho. So rho 1 is for the satellite 1, square root x1 minus x0 power of 2 plus y1 minus y0 power of 2 plus z1 minus z0 power of 2. Then in the next line, we need to do the A matrix. A11 is A rho 1, column 1, which is the x value. So negative x1 minus x0 divided by rho 1. A12 equals to y1, negative y1 minus y0 divided by rho 1. A13 is z value. So negative z1 minus z0 divided by rho 1. A14 is the speed of light. So use the same method for the other 3 satellites. Then next we need to do we need to align the A matrix A form. So matrix A equals to open square root. We need to align the A matrix of the 4 satellites, and we need to do a close bracket. Then this is the when we run the program, we get the result of A matrix. The first column is the x value for each satellite. The second column is the y value of each satellite. The third column is the z value for each satellite. The fourth column is the speed of light. Then we need to generate the L matrix L. So this is the formula for do the L matrix. So the R is port measurement minus with the rho and plus with the speed of light and multiply by satellite clock error. Next. So in MATLAB, the code measurement and the satellite clock error was taken from the exercise file. So the PR is pseudo range so we need to declare the pseudo range for each satellite. Then we need to declare the satellite clock error for each satellite. Then we can do the L metric formula. So after we do the L metric, we need to align the L metric. So when we run the program, we get the result of L metric. The first line is L11 is matrix L for satellite 1. The second line is matrix L for satellite 2. The third line is matrix L for satellite 3. The fourth line is matrix L for satellite 4. So next. So finally, we need to do the least square estimation. This is the formula. The x equals to open bracket A transpose A, close bracket -1, bracket A transpose matrix L, close bracket. So the AT is the A transpose. We use A apostrophe in our MATLAB. A is the matrix A. -1 is inverse. We use INV as INV in our MATLAB. The L matrix L is the L matrix L. So when we do the formula in our MATLAB, we will get the X matrix in our output. So this is the output of matrix X. So the first line is delta X, the second line is delta Y, the fourth line is delta Z, and the third line is delta Z, and fourth line is delta the satellite clock error. So the scenario is like this. We have four satellites. We have tool and the approximate coordinate. So just now we did the geometry range, A matrix, L matrix, everything. So this least square estimation help us to get the length from X point to the tool, which are the delta X, Y, Z. So to get the exact receiver coordinates, we need to add the approximate coordinate with the delta X, Y, Z. So finally, the final step is we need to do the coordinate receiver. So XR equals to X0, the approximate coordinate of X plus delta X. The YR equals to Y0 plus delta Y. ZR equals to Z0 plus delta Z. So we get the accurate coordinate of receiver X, Y, Z.
About DGPS, DGPS use code measurement. DGPS allow for correction to improve code measurement and utilization. DGPS must utilize at least two receivers that use similar set of satellites, which is reference station and user station. Communication medium to allow for correction sending to the user from reference station. Next. The concept of code measurement, code-based differential GPS DGPS is a technique for reducing in error in GPS derived positions by using additional data from a reference GPS receiver at a known position. The most common form a DGPS involves determining the combined effects of navigation message epidemics and satellite clock errors at a reference station and transmitting correction in real time to a user's receiver. The user receiver applies the correction in the process of determining its position. This causes some error source to be cancelled and reduced over this. Why the DGPS is necessary for GPS application? Basic GPS can help you to find a way to the harbor, but DGPS is put you in the center of the channel. Position domain approach versus satellite by satellite approach. So we can see here two types, which is block shift and then satellite by satellite approach. For the block shift, if we want to do the block sheet, it must has unknown precise coordinate, which is x1, y1, z1. Then it must generate its navigation solution, which is x2, y2, z2. Then the correction in term of dx, dy, dz is equal to x1, y1, z1 minus x2, y2, z2. The reference station send the correction by using radio link or internet communication. The user generates its navigation solution, which is x3, y3, z3. User apply the correction, thus improved coordinate is x4 is equal to x3 plus dx, then y4 equal to y3 plus dy, then z4 is equal to z3 plus dx. Advantage is easy to implement. Disadvantage is local obstructions as well as increasing distance between the reference and rover stations will result in different satellite in view for both stations. To use the block shift, if all the set of satellite is same can, but if the set of satellite not same, we cannot use this block shift because it calculates the position domain based on coordinate, not the satellite. So we can see that here got four stations, S1, S2, S3 and S4. So how the reference station calculate the correction? So we need to use the row formula, which is xs plus x1 square plus ys plus y1 square plus zs plus z1 square, and we need to square root everything. So here we can see the diagram where have been drawn. We need to correct the first line. We need to compute the distance, which is geometry range. And then the second line is the distance of user, which is pseudo range. And then the remaining will be the distance of code measurement. So the correction, pseudo range correction, it can be ionospheric delay, tropospheric delay, orbital errors, multipath or clock errors. So how the user apply the correction? The corrected range is equal to user got pseudo range, and the corrected range is equal to pseudo range plus 1 minus correction, which is from reference station. Then the reference station send the correction by using radio link or internet communication. User will receive correction that is pseudo range from satellite. Hence, they need to apply pseudo range to get distance, thereby d minus c equal to e. D is pseudo range, E is corrected pseudo range, C will be the error. DGPS accuracy factors affecting is DGPS accuracy, accuracy of the reference station coordinate, computation of PRC and PRC dots, reference station receiver clock error. What is mean reference station receiver clock error, which is computation strategies, reference station receiver noise, rover reference suppression distance, differential correction latency, application of the correction in the rover's positions estimations, which is keep in mind that the rover is also estimating its position using their observed ranges. Rover's receiver clock error, rover's receiver noise. DGPS implementation. We have two types of implementation, which is local area DGPS and wide area DGPS. So the local area DGPS is a basic navigation system used in specific area to attain high accuracy. However, local area DGPS is expensive because stations are required in every area for applying error values between stations and receivers. Therefore, it is limited to areas where extremely accurate measurements are required, such as runways and harbors. Wide area DGPS is used to overcome the area and cost limitation of local area DGPS. It has a wide area hub station monitoring wide area reference station in every location. It provides greater range at lower cost than local area DGPS, but it is less accurate than local area DGPS. So here's the figure that shows the local area DGPS and wide area DGPS.
We are going to see the GPS network processing, RTK and NRTK rate. So next slide. Firstly, we are going to see the single baseline processing RTK. RTK is the coordinate of roving receiver, is computed in near real time by the roving receiver once it received carrier phase data from the base station via communication like radio link or internet based. When the baseline length increases, the error at reference and rover receiver become less common and therefore cannot be cancelled out properly. This causes to lower positional accuracy when the longer distance was established by during the single baseline RTK positioning. Next is network baseline processing, NRTK. RTK means real-time kinematic. It is a carrier-based positioning by combining and interpolating measurement from a network of reference station. For example, continuous operating reference station known as CORS or permanent GPS station. In Malaysia, we have type 1 and type 2 CORS station as we see the diagram beside. So GPS or GNSS, continuously operating reference station CORS, is a facility to collect and record continuously in an automatic manner the GPS or GNSS data at a specific location. CORS of global, regional, or local scale have been established in many places around the world to support positioning activities and applications. Nextly, we're going to see the network baseline processing. How it works. The network baseline processing is the act of measuring and rating the performance of a network in real-time situation. Providing a network baseline requires testing and reporting of the physical connectivity, normal network utilization, protocol usage, peak network utilization, and average throughout of the network usage. So as summary, next slide. Although network RTK perform more homogeneous and more accurate result when compared to the single baseline RTK, both approaches provide positioning with a few cm level of accuracy when the fixed solution is obtained. In general, both single baseline and network RTK derived coordinate agreed with the relative positioning solution at a few cm level of accuracy in both 2D position and height component. The RTK used make their continuous real-time positioning very reliable, fast, typically in within few minutes, cost-effective within cm to dm level of accuracy. The single baseline or network RTK approaches are an attractive alternative to conventional relative positioning method that require expensive and time-consuming fields of office processes. On the other hand, although RTK system is especially network RTK are being used more widely in different projects each day due to their several advantages, need for base station with enough density for a communication like Wi-Fi, internet, more complicated and more expensive infrastructure are the restricting factor in such system.
For the conclusion, GPS is absolutely a network of satellite that continuously transmit coded information, which is made possible precisely identify locations on Earth by measuring distance from the satellites. Initially developed for military use, and now GPS is a part of everyday life, such as mobile phones and car navigation, and also search and rescue equipment. Other than that, the accuracy of GPS measurement satisfies the requirements of some applications, from the coast-based measurement to carrier phase measurement, and also from navigation to surveying. Lastly, its application field is vast, and new applications will continue to be created as the technology evolution. That's all from us. Thank you.